Going to be reviewing, again, ignore those titles. This is the 7.6/7.7 worksheet. Number one is a review question. Go back and look at the 7.5 video I made that covers that type of question. Number two is definitely review from previous videos. Go back to previous worksheet videos to look for questions like that. I want to spend time in this video on two problems, number 3 and number 5. Let's look at number 3 here. So it says, are the two triangles above similar? So by now you should know we have 3 similarity theorems. We have angle, angle, similarity theorem. We have side, angle, side, similarity theorem. And we have side, 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 similarity theorem. So it has to be one of these 3 in order to prove that these two triangles are similar. You can see that they gave us no angles that are either congruent, and they didn't give us any measurement of any angles at all. We don't know the measurement of any angles, and we don't know if any of them are congruent. So with that said, we cannot use angle, angle because we don't know any angles, right? And guess what? We cannot use side, angle, side because, again, we don't know any angle measures, or we don't know if any of them are congruent, and there's no way to prove that they are. So if these triangles are similar, it's going to have to be because of the side angle, or the side, side, side similarity theorem. So that doesn't mean that automatically they are. We have to check them. So how do we do that? We're going to check to see if all of the corresponding sides are proportional to one another. So let's start. Let's look at the first triangle, RP. Okay, RP is the longest side in that triangle. What is the longest side in the second triangle? Hopefully you're saying 25 because it is so. So therefore they correspond to one another. The longest side will always correspond with the other longest side. Same goes with the shorter side. So RQ is the shortest side in this triangle. It will correspond with the shortest side in this triangle. So those two sides correspond to one another, which leaves the last pair of sides, ED, will correspond to PQ because those are the middle sides, if you will. Let's write all those sides as ratios. So let's start with the longest side. So I'm going to say 30 over 25. Let's start with the second longest side. So I'm going to say 24 over 20. And the third longest side, or the shortest side, 18 over 15. And we are simply going to check to see if these ratios are all equal to each other. How do we do that? We can very easily do that by just dividing them in a calculator. So 30 over 25, I'm just going to type in 30 divided by 25. That gives me 1.2. So I'm going to write 1.2. So guess what? If these triangles are going to be similar, all of these ratios have to be 1.2. Let's check them out. 24 divided by 20. That's going to give me 1.2. Almost there. We just need to check the last one. 18 divided by 15 definitely gives me 1.2. So now that I've checked them all, we can see that they are all proportional to one another, and therefore we can say, yes, these triangles are similar because of side, side, side similarity. So that's what your proof is saying. You're saying you should say, since all 3 pairs of corresponding sides are proportional to one another, then you can say triangle RPQ, or however you want to name it, that is similar to triangle. So if we say RPQ, we better say FDE if we're going to say in proper order. So then we can say then triangle RPQ is similar to triangle FDE because you must always give a reason of side, side, side similarity theorem. Next question, 5. So it's saying, are these triangles similar? So our 3 similarities theorems are angle, angle, side, side, and side, side, side. Well, by looking at it, hopefully by now you guys should notice really quickly that you have a pair of angles here that are congruent. Those are called vertical angles. We covered that in class. And we don't have any other angles that we can either say are congruent, and they didn't give us any measurements. So we only have one pair of angles. So therefore, we have to throw out angle, angle. We can't use that because we are going to need two pairs of angles, and we don't have that. We do have one pair of angles here. Notice how we can't use side, side, side either, because you're going to need to know all three sides. So you'll notice we don't know the measurement of EG and XY, and there's no way to figure those out. So we have to throw out side, side, side. So the only one that's going to work is side, angle, side. Now, that doesn't mean that it is. We still have to check it to see if it works. So how do we do that? We need to correspond the side lengths and check to see if they are proportional. So let's take the longest side in this triangle, this first triangle, which is EF, and correspond it with the longest side in the other triangle, which is YF. And that's going to correspond. And then the shorter of the two sides in each triangle is going to be GF and XF. And let's just go ahead and write a ratio for each of those. So we're going to say 24 corresponds to 21, 16 corresponds to 14. And let's check if they are the same ratio. You can do so by just taking a calculator and dividing 24 divided by 21. Okay, that gives us 1.1428. So we got to remember that. So let's write that 1.1428. It does continue. So let's write 16 divided by 14. And look at that, 1.1428. So they are indeed the same proportional. And guess what? The angle that is in between the sides, it has to be in between, is congruent because those are vertical angles. So we can say that yes, these triangles are similar because of side angle side similarity. So that's what this part is saying right here. It's saying angle what? So we can say angle EFG. That's this angle right here. Angle EFG. EFG is congruent to angle XFY. XFY. And then the last part, side angle side proof. So we need to say since, we can say since two sides, two pairs of corresponding sides in one triangle or in each triangle are in the same ratio to another pair of corresponding sides in those same two triangles, and the angle that is in between them is congruent, then these two triangles, you're going to name your triangles triangle blank, similarity statements, and then you can say, why are they similar? You can say because of side, angle, side, similarity theorem. So I didn't want to write that out for you. You guys need to get the practice of that. So it should say something like this. Since we have two pairs of corresponding sides that are proportional to one another, and the angle that is in between each of those sides, so the angles that are in between each of those sides, EFG and XFY, they are congruent because they're vertical angles, then these two triangles, name them, are similar because of side angle side similarity theorem. Okay? And the rest of them is just some review stuff and same type of questions that you guys can be working and trying on your own.